Today we're going to talk about a new way to solve quadratic equations called the quadratic formula. So far that we have learned 4 ways to solve quadratic equations. The first way we learned was factoring, which will not work always, and when we have a number for a, sometimes that can be a little complicated. The second way we learned last week, we talked about graphing, and remember the solutions are the same thing as the zeros where the parabola crosses the x-axis. But again, that was a lot of work. The third way we learned was taking square roots, which is ideal, but not everything is in the correct form for that always, which then we talked about using completing the square yesterday, which again can get a little bit complicated. On Monday we'll talk about the different ways on how when we'll use each of these. And today we're going to learn a way that works always, and that's called the quadratic formula. Before we show it to you, brace yourselves, it looks a little complicated. So let's go ahead and let's write this down. It's negative b plus or minus the square root of b squared minus 4ac all over 2a. And in class we'll talk about ways that we can memorize this, because you will need to have this memorized. So in order to use the quadratic formula, first thing we're going to do is we're going to write this in the form ax squared plus bx plus c is equal to 0. And remember, we're using those same letters to represent the coefficients and constants for ax squared plus bx plus c. Once we have identified a, b, and c, we'll go ahead and write a equals, b equals, and c equals, and this will help us to stay organized. And then once we've got them labeled, we're just going to plug them into our formula and we're going to solve the equation. So we're going to go ahead and go through a couple with you, and then we're going to let you try some. So here's our first equation, x squared minus 12x minus 14 is equal to 0. It's already set equal to 0, so we can identify a is equal to 1, b is equal to negative 12, and c is equal to negative 14. It's important that you don't forget your negative signs, because if you do, that's probably going to mess up most of your work. So the first thing we're going to do is we're going to go ahead and we're going to plug it into our formula. And I've listed the formula on each problem. You don't need to do that in your notes unless you're working on memorizing it. So here's our formula. So the opposite of negative 12 is positive 12 plus or minus the square root of 12 squared, and that should be negative 12 squared, excuse me, minus 4 times 1 times negative 14. So then that'll all be over 2 times 1, because our value for a is 1. So we've plugged that in, then we can go ahead and evaluate using the order of operations underneath that square root symbol. So 12 squared will be 144, and 4 times 1 times 14 will give us plus 56. Remember, we have a negative sign here and a negative sign here, and that'll give us a plus sign here. And that'll be over 2. We can go ahead and do 144 plus 56. So now we have 12 plus or minus the square root of 200 divided by 2. We've simplified this as far as we can, and now we're going to go ahead and write our 2 math problems. So we'll do 12 plus the square root of 200 and 12 minus the square root of 200. So when we do 12 plus the square root of 200, we'll get 14.4 for the square root of 200. So we'll do 12 plus 14.4 divided by 2 will give us 26.14 divided by 2, and our first solution is 13.07. To find our second solution, we'll do 12 minus 14.14 divided by 2, which will give us negative 2.14 divided by 2, and then when we go ahead and do that division problem, we'll get negative 1.07. So you can see that these problems have a lot of work, but if it's plugged in correctly, it's pretty much foolproof. If you need to pause it so you can make sure you get that all written down, go right ahead. Otherwise, we're going to move on to the second example. Okay, we have 5x squared minus 3 is equal to 4x. So we can see that it's not in the correct form, so we need to rewrite this equation to be 5x squared minus 4x minus 3 is equal to 0. Now that we've got it in the correct form, we can identify that a is equal to 5, b is equal to negative 4, c is equal to negative 3, and then we can plug it into our quadratic formula. When we do that, we'll have the opposite of negative 4 is positive 4 plus or minus the square root of negative 4 squared minus 4 times 5 times negative 3. And that will all be over the quantity 2a, so 2 times 5. So you can see that we've taken these values up here and plugged them in right here to our formula. Then we can start to evaluate and simplify what's underneath that square root symbol. So 4 squared will be 16 minus 5 times 4 times 3 will be 60. When we have the negatives, that will become plus 60, and that will be divided by 10. 4 plus or minus the square root of 16 plus 60 will simplify that to be 76. And that's still being divided by 10. And remember, now that we're here, we're going to break it into two separate math problems. So 4 plus the square root of 76, which we will evaluate to 8.72, and 4 minus 8.72. We'll do one at a time. We'll simplify and get 1.272, and then negative 4.72. Usually we're going to round to the nearest hundredth, but since this was an even thing to divide by 10, we can go ahead and leave all of those decimals. For our third example, remember we have 9x squared plus 3x plus 7. So we need to set this equal to 0 by subtracting 7. And once we do that, this will be our new equation, 9x squared plus 3x minus 7. So we have a is equal to 9, b is equal to 3, and c is equal to 7. And right now, it would be a good idea for you to pause the video and to try this problem on your own. Hopefully you paused it and you're not cheating, and you can go ahead now and we'll show you how to get your solution with the work. We end up getting 0.73 and negative 1.07, and hopefully you were able to get those on your own. So here's it worked out if you were not able to. Onward. Alright, now we're going to look at two different cases. What happens when something weird or different happens underneath that square root. So this we have, it's already in the correct form, 10x squared minus 7x plus 5, so we can identify a equals 10, b equals negative 7, and c equals 5. Once we've done this, let's go ahead and plug it into our quadratic formula. So that will be positive 7, because that's the opposite of negative 7, plus or minus the square root of negative 7 squared minus 4 times 10 times 5 divided by 2 times 10, because our a value is 10. Let's first evaluate what's underneath our square root symbol. So 7 squared will give us 49, and then negative 4 times 10 times 5 will be negative 40 times 5, so minus 200 over 20. We're continuing to evaluate what's underneath our square root symbol. 49 minus 200 is going to give us a negative 151. Now hopefully you remember that you cannot take the square root of a negative number. So right here, we're going to know that since we can't take that square root symbol, we're going to be able to say that we know that we are unable to evaluate that, and we're going to actually have no solution. We'll talk on, when we're back in class, how the graph of this, that means this graph is never going to touch the x-axis. That's what that graph is going to look like, so this will have no solution. And number last. X squared minus 16x equals negative 64. Again, we're going to need to set this equal to 0, so we're going to add 64 to both sides. So our new equation that we're working with in the correct form is x squared minus 16x plus 64. Forgot my x here. Oops. There we go. So we can go ahead and we have a is equal to 1, b is equal to negative 16, and c is equal to 64. You might recognize this as the perfect square, and we'll talk about how that's going to affect our answer here. So we plug in what we have, 16 plus or minus the square root of negative 16 squared minus 4 times 1 times 64, and that will all be over 2 times 1. When we evaluate underneath this square root symbol, negative 16 squared will give us 256. 4 times 1 times 64 will also give us 256. So here's our new problem, 16 plus or minus the square root of 256 minus 256 over 2. When we subtract 256 from 256, we're going to get 0. So now we're working with this problem, 16 plus or minus the square root of 0. Hopefully you understand that the square root of 0 is 0. So if we were to do 16 plus 0 divided by 2 or 16 minus 0 divided by 2, we're still just doing 16 divided by 2. So we're only going to have one solution, which is going to be 8. Tomorrow in class we're going to practice using the quadratic formula, and then tomorrow night we're going to talk about how you know by looking at just part of the equation how many solutions you're going to have. So we would like you to try these 3 problems on your own. You're definitely going to need to try these on your own paper, and you will probably need to use a calculator. We'll leave the quadratic formula here for you if you need it. And please be sure that you have the quadratic formula memorized. See you tomorrow.